For decades, nuclear fusion has been the holy grail of clean energy, offering the promise of an endless, sustainable, and carbon-free power source. But despite its immense potential, the journey toward practical fusion power has been long and filled with scientific challenges. Today, however, a groundbreaking development at the Lawrence Livermore National Laboratory is bringing us closer than ever to realizing that promise. This new innovation could change the way we think about energy forever, introducing a revolutionary 3D printing technique known as dual wavelength 2-photon polymerization or DW-2PP. This cutting-edge method is being used to create fuel capsules for nuclear fusion, capsules that are critical for making fusion power plants a reality. Fusion energy, the process that powers the sun, has long been the holy grail of energy research. It holds the key to virtually limitless, clean and sustainable power. Unlike traditional nuclear fission, which splits atoms, fusion combines light atomic nuclei such as deuterium and tritium, releasing massive amounts of energy. Fusion research dates back to the mid-20th century. In the 1950s, scientists began exploring ways to harness the power of fusion. Over the decades, advancements in magnetic confinement fusion and inertial confinement fusion (ICF), using powerful lasers to compress fuel pellets, brought us closer to practical fusion. But one of the biggest hurdles has always been the production of the fuel capsules that hold the fusion fuel. These fuel capsules must be nearly perfect. Any flaw, even microscopic, could cause the fusion reaction to fail. Currently, manufacturing these capsules is a painstaking, time-consuming process that takes months to complete. To give you an idea, to power just one fusion plant, you'd need nearly 1 million capsules every day. Enter 3D printing. This breakthrough technology is now being used to revolutionize capsule production. At LLNL, scientists have developed a dual wavelength 2-photon polymerization DW-2PP approach, which utilizes two different light sources to create intricate, high-resolution structures. This technology allows for the printing of complex, defect-free geometries with sub-micron precision. Why is this important? The answer lies in scalability and precision. With traditional manufacturing, creating one capsule can take weeks, but 3D printing could potentially reduce that time dramatically while producing fuel capsules in the quantities needed to run a fusion power plant. These new wetted foam capsules are designed to wick liquid deuterium tritium DT fuel into a uniform foam layer inside the spherical capsule. The current process for adding this DT fuel takes up to a week to complete with extreme accuracy, but the new 3D printing technique could accelerate this process, all while maintaining the level of perfection required. In fact, this innovation has already been put to the test. In 2024, 3D printed fuel capsules were successfully used in 2 fusion experiments at LLNL's National Ignition Facility. These successful trials are a clear indication that 3D printing could be the solution we've been waiting for to solve the fuel capsule bottleneck. Why does this matter? Because fusion energy has the potential to transform our world. It promises a future where we rely on an almost unlimited supply of clean, safe and abundant energy. But to make that future a reality, we need to solve critical engineering challenges like the production of fusion fuel capsules. As we push closer to commercial-scale fusion energy, overcoming manufacturing challenges is crucial. 3D printing is now helping us scale up production, ensuring that we can meet the demand for these fuel capsules. This breakthrough not only accelerates the timeline for fusion power plants, but strengthens the US's position as a leader in fusion energy technology, and the implications go beyond just energy. The precision manufacturing techniques developed for fusion fuel capsules could have far-reaching applications in fields like aerospace, medicine, and nanotechnology. We've come a long way since the early days of fusion research. The milestone of fusion ignition achieved at LLNL in 2022 was a giant leap forward, but as we know, a breakthrough alone isn't enough. We need to build the infrastructure, the systems, and the technology to bring fusion from the lab to the grid. With each step, we're pushing the boundaries of science and technology, moving closer to a world powered by the clean energy of the future. Fusion is no longer just a dream, it's becoming a reality. If you enjoyed this deep dive into the future of fusion energy, Make sure to hit that like button, subscribe to stay updated on the latest breakthroughs, and comment below with your thoughts or questions.